All right, we've reached the cool down for lesson 2.9. I hope you've tried to answer this before you've looked at the video, but it's just basically wanting us to describe the end behavior of this given function. And one of the biggest things you needed to take away from lesson 2.9 is that the degree and the leading coefficient really are the only term that determine what the end behavior looks like. So I'm going to circle that guy. And we're going to write down that this is a degree equal to 4. So this is an even degree. So this is even. Now, an even degree basically means that our end behavior is going to go one of two ways. We are either going to be going in the same direction, where we're both going up, or we're going to go in the same direction when we're both heading down. How do we know? You could take a long way and you could, test out a positive x value and plug it into the function to see whether we're going to get a positive y value, right? Because the first quadrant is positive x, positive y. Or you could test it out, and if you tested out a positive x value and you got a negative y value, then you definitely know it's going to be the second option. So let's go ahead and test out a number. You want to test out a number larger, a little bit further away from 0. And I'm going to go ahead and test out. Let's go ahead and put 20 into the function and see if we get a positive or a negative. So we have a negative 20 to the 4th plus 20 squared minus 20 plus 1. And we want to see if that's going to give us a positive or a negative. I don't really care what the value is. So I can already tell that 20 to the 4th is a ginormous number and it's a negative. So I know that this is going to be a really, really, really big negative number. This is going to be a somewhat big positive, but not big enough to cancel out with those negatives. And this is a tiny negative number and this is a positive. So I know that overall, if I had to use reasoning, that this 20 is going to give me a negative number. And you can, of course, plug it into the calculator. So with that in mind, I know that somewhere over here at 20 comma something, we're down here in the negative region. So I know that my end behavior is going to be this graph. This is definitely what my end behavior looks like. So if I were to write it out in the terminology that they're using, as x approaches larger positives, my y is approaching larger negative values. And then as x approaches larger negative values, y is also approaching, still going in the same direction, larger negative y's. So as x gets larger and larger in both directions, positive or negative, so that's important, in both directions, my output values, remember output values are just y, gets larger and larger in the negative direction. And I did, just to reaffirm this, I did graph it on Desmos to double check, and that is the graph of this function on Desmos. The ends of this polynomial are both heading in the same direction because it's even degree, and they are both heading down. They are both getting larger and larger in the negative direction.